Hello there, seventh graders. Real quick, before I get started on talking about this particular lesson, I want to point out a few things when you watch the videos. First thing that you're going to see is that there's going to be a target written at the top of the screen. I'll read over that and try to break it down as to what we're specifically looking for. The other piece is you will see this, a number with some letters followed by another number and maybe a letter after that last number. But what this is pointing out that this is a seventh grade target. It has to deal with the domain or area of math of ratios and proportions on this one, hence the RP. And the one is the standard number. Okay? And standard number is specifically what do you need to do in ratios and proportions for seventh grade. And the first standard that we're going to address is this, written as a target, mind you. I can compute unit rates associated with ratios of fractions, including ratios of lengths, areas, and other quantities measured in like or different units. So to start, we're going to look and see exactly what is a ratio. So a ratio is a comparison of two numbers, and that's all it is. So it's taking two numbers and writing them in one of three ways. So we're going to look at 2 to 5 as a ratio. One way to write that is in a fraction form. The first number that is said is in the numerator position, the second number in denominator position. Another way to write a ratio is saying 2 with the word spelled out 2 to 5. And a third way is using a colon in between them, saying that I am comparing 2 to 5. More often than not, you are going to see ratios written this way and this way, occasionally here, but what we're going to look at most is in fraction form and with the colon. Ratios generally have something attached to them, and that's what we're talking about as far as quantities measured with like or different units. So for example, thinking of football right now, a quarterback can have a ratio of completions to incompletions or completions to total passes, and that's what we usually see. So for a quarterback, we want to see how many completions out of their pass attempts. These are two different things. Pass attempts. So for example, a quarterback may have thrown the ball 35 times in the last game and had 25 completions. So the ratio is 25 completions to 35 pass attempts. So we have a label there that gives us what we are talking about, the completions to pass attempts. We could simplify this down. Since they're both a multiple of 5, I could divide both of these by 5 and say in simplest form that for every 5 completions, this particular quarterback had to have 7 pass attempts for that game. So every 7 times the quarterback threw the ball was completed 5 times. Okay, so that's a quick way to write ratios. The next piece is what exactly is a unit rate. And I think to go over this one, I'm going to use an example that most of us are probably fairly familiar with. And what that is talking about speed. How fast does somebody travel or does somebody go? So to use that, I'm going to write a ratio, and that ratio is going to be 500 miles in 8 hours. And this is kind of an average of what, when I was traveling to and from Seattle to come back to Missoula when I lived in Seattle, what I would normally expect. To drive that 500 miles, I'd kind of budget myself 8 hours. But what I want to know is really how fast am I traveling for one or in each hour? How far am I traveling? And that gives me my speed. So how do I compute that? Just like equivalent fractions, and like we did up here in simplifying equivalent fractions, I want to find what both of these numbers are divisible by. So a multiple of each of these. However, with the unit rate, what I'm going to divide by is actually given to me already. I want to know what it takes for 1 hour, a unit. A unit equals 1 of something, and in this case it's hours. So how do I get from 8 to 1? Okay, when we think equivalent fractions, I know that I am going to divide this by 8. And when we talk about equivalent fractions, I want to do to the numerator what I do to the denominator, and the reason being in this is what we're going to talk about ad nauseum, so get used to this, is when I divide by 8/8, 8/8 is a form of 1, and when I divide by 1, that number doesn't really change. The values in numerator and denominator are going to change, but because you divide by 1, it's equivalent. Any number divided by 1 is that same number. So I take 500, I divide it by 8, and end up with 62 and 5/10 miles. So my speed is 62.5 miles per hour. We will see unit rates as generally talked of and said as per whatever the unit is in the denominator. So this is a fairly basic unit rate problem. We'll look at some more in class, but we're going to also look at some more complicated unit rate problems. So this is just a scenario. If a person can walk, they can walk a half mile per hour, which is at a fairly slow pace. How far will they walk in 2 hours? So a half mile per hour. So I have that 1/2 miles, and it's per hour. That's my unit rate. So we're looking at a 2-hour time frame. How do I get from 1 hour to 2 hours? And this is the notion again of equivalent fractions. I'm going to multiply this by 2. We would get 1 mile in 2 hours. Okay? The complex part comes when we have a fraction or a decimal within that ratio, and that is okay. You may have been told you can't have a fraction within a fraction. However, we can do that. Okay? One other scenario, and I'm going to use this half mile again, but I'm going to change what that time frame is. We will say that a person can walk 1/2 mile in a quarter of an hour. What is that person's unit rate, or what is that person's speed for 1 hour? What does that equal? Okay, so we're going to set this up the same way. However, it's going to look a little weird. When we have miles per hour, we're going to ignore the numbers right now. What is miles per hour? What are we comparing? Miles to hours or hours to miles? We are comparing miles to hours. So in that fraction, it's the first thing that we are talking about, in this case miles in the numerator position, the second thing hours in the denominator position. And I am going to fill in those fractions. Some of you may be comfortable seeing this, some of you might see this as a little bit weird, but we're going to keep it just like this. Because what we want to look at is, how do I compute a unit rate? Unit being 1. How do I get to 1 hour? That's what I want to see. Whatever that denominator position is, that's the unit that we're converting to, the unit, the 1. So this is what we talked about in the previous weeks. Fractions, fraction operations. How do I get from 1/4 to 1? We talked about that, and there's a word that we talked about, and it's the multiplicative inverse. And a multiplicative inverse is when I take a number and I multiply it by its reciprocal, I get a product of 1. So what do I multiply 1/4 by to get a product of 1? I see it as, well, in order to get 1, I need to have that denominator, how many pieces it takes to make a whole, stays the same as 4. How many pieces do I have? That numerator does it take to make 1 whole, and that is where numerator and denominator are the same. So I'm multiplying by 4 as a whole number, or 4/1. So in this case, we're going to talk about multiplying by 4. What I do in the denominator, I need to do in the numerator, because it's multiplying by a form of 1, 4/4. And fraction operations, again, I have 1/2 and I multiply it by the whole number 4. We talk about, we're comfortable with multiplying fractions by fractions. 4/2. Simplify 4/2. 4/2 simplified ends up being 2. So if a person walks 1/2 mile per quarter hour, how far will they walk in 1 hour? They will walk 4 miles. So we're about at that 10-minute mark. I'm going to try to keep all these videos right around 10, 11 minutes or less. You can refer back to these if you need to. In the future, I'll try to let you know exactly what the standard is that you're looking for. If there's a review that could be helpful for this. So I'm going to leave one thing for you. And this is going to be your warm-up question for tomorrow, and that warm-up question is going to be this: if I buy 15 pounds of ham, we're having a Super Bowl party or something, making sandwiches, 15 pounds of ham, and it costs me $45. I want to know what is the cost per pound, LB per pound. So again, cost being the dollar amount, being pounds. I will set you up at this point right here. We're talking $45 per 15 pounds. What is that for 1 pound? Again, equivalent ratios, equivalent fractions, dividing by the same number, and the number is given to you, which is nice when we're talking unit rates. That number is whatever the value is down here. If it is above 1, divide denominator portion by 15 and the numerator portion by 15, and you get 3 pounds. Put the dollar sign where we normally see it. 3 pounds per dollar. $3 per pound, excuse me. Have a great night.